In this video, you're going to set up the triple integral given a 3D shape. So we have a polyhedron right here with the points 1, 0, 0, 0, 2, 0, and 0, 0, 3. We want to begin by finding the equation of this polyhedron. And because they don't give it to us, we're going to create the equation using a quick way I have here. All you need to do with this way is to write down the coordinates. So we have the x coordinate, which is 1, y coordinate, which is 2, and z coordinate, which is 3. We then want to find the least common factor for this, for all these three numbers. And in this case, the least common factor for 1, 2, and 3 is 6. Now, we're going to set up our equation like this. If you look here, how many times does 1 go into 6? 6 times, so it's going to be 6x. How many times does 2 go into 6? 3 times, so it's going to be 3y. How many times does 3 go into 6? 2, so it's going to be 2z. Now this is your equation for this polyhedron. The next step you want to do is you want to set up the triple integral. So 1, 2, 3, dz. And you can either find dx dy or dy dx. In this video, I'm going to find dy dx. But it is always good, it's always the most appropriate way to put dz before these two. It's just easier that way. Next step you want to do is you want to find the inner boundaries for dz. And in order to find, we know for a fact that the lower boundary will be 0 because this polyhedron ends at 0 on the z-axis. So what we want to do is we want to solve for z in this equation. So you want to isolate z. You then have 2z equals negative 6x minus 3y plus 6. Divide 2 on all of these terms. You get z equals negative 3x minus 3 over 2y plus 3. This value right here is going to be your upper boundary. So you have negative 3x minus 3 over 2y plus 3. Okay, now how do we find the boundaries for y? In order to find the boundaries for y, you're going to make a graph and set z to be equal to 0, okay? So you're making this graph. This is the y-axis, this is the x-axis. Now you want to draw the shape, okay? So if z is 0, this point right here is going to be 0, 2 for the y, 0, 2. And this point is going to be 1, 0. So 1, 0. You're going to have a shape like this. Now, we want to set, now that we have z equals 0, our equation will look like this. 6x plus 3y equals 6, okay? We then want to solve for y. So 3y equals 6 minus 6x, or 3y equals negative 6x plus 6. Divide 3 on all of these terms. You have y equals negative 2x plus 2. Now this is going to be your boundary right here, negative 2x plus 2. And we know for a fact that it ends at 0 because this shape ends at 0. The boundaries of this shape for in the y-axis is 0 for lower boundary. Okay, we have one more to do. For the dx boundary, in order to find this dx boundary, look at this graph right here. Okay, this is our slider on the dy dx. This slider can only go as far as this point. So the lower boundary will be 0 because this point is at 0.00. And it can only go as great as this point. And this point is 0. No, this point is 1, 0. So the x coordinate is 1. Therefore, the upper boundary for dx will be 1. Now you have a triple integral set up for this polyhedron.